Today we are going to learn chapter 18, exchange rate. The course targets for this chapter are the understanding of real exchange rate, the meaning of purchasing power parity and relative purchasing power parity. And then we'll end the chapter with interest rate parity. The reading for this part is textbook chapter 18. First, we want to understand the definition of real exchange rate. We start from nominal exchange rate. In our daily life, we see nominal exchange rate like the following one, that $1 may be equal to 0.88 euro. So this number 0.88 actually is called the nominal exchange rate of $1 against euro. Then for money, it actually is involved with some kind of a real value. And what's the real value of money in terms of its purchasing power for each currency? For US dollar, it can be used to buy US basket of goods. And euro dollar can be used to buy euro basket of goods. These two baskets may look totally different. And for the US basket, suppose each basket is $5. Then only one US dollar bill is equivalent to owning the purchasing power of 0.2 units of US basket. Following the same argument, if euro basket costs 2 euros, then owning 1 euro is like owning the purchasing power of 0.5 unit of euro basket. So if we use the notation P to denote US basket price, then the purchasing power of $1 is 1 divided by P. If we use PF to denote the basket price of euro basket, then owning 1 euro is equivalent to owning 1 divided by PF units of euro basket purchasing power. Now we want to ask ourselves, when we trade in US dollar for euro bills, what are the purchasing powers involved? Remember that the purchasing power of $1 is 1 over P unit of US basket. And the purchasing power of 1 euro is equal to 1 over PF unit of euro basket. So when you own $1, which is equivalent to 0.88 euro in the foreign exchange market, then if you give up $1, you can gain 0.88, which we use the notation epsilon unit of euros. So this epsilon unit of euro, it will give you the purchasing power of epsilon divided by PF euro basket. Therefore, when you exchange your money from US dollar to euro, you are actually exchange your US purchasing power 1 over P to euro purchasing power, which is equivalent to epsilon divided by PF. Here, given the number 0.88, which means that when you are trading away $1 to get 0.88 euro, you are sacrificing 0.2 unit of US basket for 0.44 unit basket of euro goods. So 0.88 is the nominal exchange rate for currencies. And here we already know that when you exchange currency, you're sacrificing 0.2 unit of US basket for 0.44 units of basket. And then if we look closer, we know that for $1, you can exchange it for epsilon unit of euro. This kind of currency exchange is like giving away 1 over P unit of US basket in exchange for 1 over PF times epsilon units of euro basket. And if you exchange P US dollars, which would give you P epsilon euros, then this kind of exchange behavior is like you are sacrificing 1 unit of US basket in exchange for the purchasing power of 1 over PF times P epsilon units of euro basket. We rewrite it in this way, and then this expression is called the purchasing power trade-off behind currency trades, and we usually call it the real exchange rate of US dollar against euro. Now we are going to talk about purchasing power parity. So far we already know nominal exchange rate, which is like this one US dollar can be exchanged for epsilon unit of euros. And we know that for any currency exchange, it is involved with the trade-off between the purchasing power for each local basket. In the US versus euro example, the currency trade involved with sacrificing like 1 unit of US basket in exchange for the euro basket in turn of the unit of P over PF times epsilon unit. And if US basket and euro basket, they are very similar, and suppose there's no trade barrier, then it is very intuitive that if you sacrifice 1 unit of home basket, which will look exactly the same as foreign basket, then you will expect to get the same purchasing power back. Based on that argument, it means that this number should be equal to 1. So if you believe that these two countries' baskets are similar and the trade barrier is low and the transaction cost is very low, then the real exchange rate between US and euro dollar should be equal to 1, which is called purchasing power parity. Now we move on to relative purchasing power parity. Earlier we said that if home basket and foreign basket look very similar and there is no trading barrier and no other transaction cost, then real exchange rate should be equal to 1. But in reality, home basket and foreign basket, they are so different, and also there are all kinds of transaction costs. Therefore, real exchange rate between two currencies is usually equal to some number k, which may not be equal to 1. And if we assume, however, k to be some stable number, then it means that though real exchange rates are different than 1, but tomorrow's real exchange rate will be equal to today's real exchange rate. If we rearrange the equation, then it will give us the following expression saying that the price growth of home country P and over the price growth of foreign country PF will be equal to the exchange rate today over exchange rate tomorrow, and which can be rearranged to this way. And furthermore, then we can rewrite the left-hand side of the equation as the 1 plus US inflation rate over 1 plus euro inflation rate. It will be equal to 1 over 1 plus US dollar appreciation rate. And with approximation, the equation on the left-hand side can be written as 1 plus US inflation rate minus euro inflation rate. Following the same approximation, then on the right-hand side, it can be approximated with 1 minus the US dollar appreciation rate. This gives us the final parity, which is saying that foreign inflation rate minus home inflation rate will be equal to home currency appreciation rate. This is called relative purchasing power parity. Finally, we are going to talk about interest rate parity. First, for today, assume that $1 can be exchanged for epsilon t unit of euro. And suppose the home interest rate, which is US interest rate, is equal to IT today. Therefore, if you save $1 today, then tomorrow you are going to get 1 plus IT US dollars. However, if you exchange US dollar into euro, you will be able to have epsilon euro that you can save in euro banks. If we assume that the euro interest rate is I star, then saving epsilon euro in euro banks will give you 1 plus I star times epsilon euro tomorrow. So tomorrow, based on these two different saving choice, one would give you 1 plus I US dollar tomorrow. The other will give you 1 plus I star times epsilon euro tomorrow. And we know that suppose the exchange rate from $1 to euro is epsilon t plus 1 euro, which means that tomorrow the exchange rate from euro back to US will be 1 euro is equivalent to 1 over epsilon t plus 1 US dollars. Therefore, the saving choice number 2, if you convert it back to US dollar, it would give you this amount of US dollar. So far, what we have is that these two saving options, one is to invest $1 in US asset, it would give you 1 plus I US dollar tomorrow. The other one is to invest $1 in euro assets and then convert it back to US dollars, which will give you this much US dollar. So as you can see that these are the return of two investment options for the same $1 US. And when you convert them back to US dollar tomorrow. So since they are the same, they are using the same $1 for investment and in turn of US dollar return, then these two options should give you the same return. Otherwise, you will not invest in the one of them. So for non-arbitrage condition, we know the following equality should hold. So if we rearrange the above equation, first we know that the ratio of tomorrow over today exchange rate is 1 plus the home dollar appreciation rate, which is US dollar appreciation rate here. And we can rewrite the equation right hand side to be this. And then we can approximate the right hand side to be 1 plus I star minus the home currency appreciation rate, which is the US dollar appreciation rate. However, when you decide to invest $1 today, no matter in US asset or euro asset, for today, you should not know the exchange rate change from today to tomorrow. This part is unknown when you are deciding your investment today. Therefore, this equality would make better sense if we replace the exchange rate change to be the expectation of exchange rate change. And then with this equality, if we rearrange it, we will know that the difference of foreign interest rate minus home interest rate will be equal to the expectation of home currency appreciation rate. This is called interest rate parity.